Three-phase circuit, questions and answers.
Okay, welcome to another episode with me, Solomon, because today we are solving questions on the three phase that we started in the previous video. So let's read the question together.
Three identical resistors are connected in star across a three-phase 415 volt supply. If each resistor has a resistance of 50 ohms, calculate A, the voltage across each resistor, and B, the current in each resistor, and C, the total power supply to the load.
Okay, so as we saw from the question told us that the connection over here is a star and the voltage supply is 415, and also the resistance is 50 ohms. And the first question wants us to calculate voltage across each resistor. Then the second one is current in each resistor. And the last one is total power. Total power. So basically, since they said it is a star connection, we've established some notion over here. The supply is always the VL. Our supply is always our VL. So VL is the supply, so it means we have VL to be 415 volts. So if you have VL, the first question said we should find the voltage across each resistor. And I told you that the voltage across each resistor is our VP, which is the phase voltage. So the phase voltage, so let's pick A. Phase voltage is going to be equal to the line voltage over root of 3. Because we've established in the previous video that the line voltage is equal to root 3 times the phase voltage. So if you need the phase voltage, you just make the phase voltage the surface. So you are going to get VL over root of 3. And what is our VL? That's 415 over root of 3. And you are going to get the phase voltage to be equal to 240 volts. So as soon as you get the phase voltage to be 240 volts, the next question that came was the current in each resistor. So when you talk of the current in each resistor, you are talking of the phase current. And you know that the phase voltage is equal to IR. But since we are talking of the phase voltage, it means we will be talking of the phase current. So the phase current is going to be equal to the phase voltage over the resistance. Over the resistance.
Get no money.
So what is our phase voltage? Already we've calculated for the phase voltage. We are 240. And what is the resistance? From the question given, it was 50 ohms. So when you put the 50 there, you are going to end up getting 4.8 ampere. So after getting the current in each resistor, now they said we should find the total power. If you want total power, first they said it is a balanced circuit. And when it is in a balanced circuit, when you find power in one phase, you just multiply that power by 3 to get the total power. So basically, C, which is our total power, is going to be equal to 3 times the phase voltage times the phase current. So we are going to get 3 times the phase voltage, which is 240, times the phase current, which is 4.8 amp. And with the help of our calculator, let's see what our final answer is going to be. We are going to get 3, 4, 5, 6 watts. So this is the answer to the first example. Now let's take the second example. Example 2. Let's read the question together.
So the question 2, or the example 2. 3 identical impedances are connected in delta across a 3-phase 415 volt supply. If the line current is 10 ampere, calculate A, the current in each impedance, and B, the value of each impedance.
Okay, so from the example that we just read, the example told us that it was connected in delta. So if it is connected in delta, what is the delta condition? The delta condition tells us that VL is equal to VP. And what is the second delta condition? That one tells us that VL is equal to root of 3 IP. So if these are the two conditions that we need to solve this question, they've given us the VL. So already we know VP. VP is also 415. But they've given us IL. How can you get IP? To get IP, we can say that, so solution A, IP is equal to IL over root of 3. Our IL was given to be 10, and 10 on root of 3 is going to give us 5.78 ampere. That is approximated to 2 decimal places. Then they said we should calculate the value of each impedance. If you need the value of each impedance, now you know the phase current, you know the phase voltage. So you know that B, the voltage across the phase is going to be equal to IP times Z. So if you need the impedance Z, it's going to be VP over IP. What is our VP? VP was given in the question to be 415 divided by IP. IP we have 5.78 ampere. So if we divide, we are going to get Z is equal to 71.80 ohms. So that's the answer to the second example. Now let's take the third example. Let's read it together. Example 3.
A 3-phase 450 volt system supplies a balanced delta connected load to a 12 kilowatt at 0.8 power factor lagging. Calculate A, the phase current, B, the line current, and C, the effective impedance per phase.
Let's take it again.
Calculate A, the phase current, B, the line current, and C, the effective impedance per phase.
Okay. So this is the third example. Example 3. So with the example 3, the question told us that it is a balanced delta connection. And when we talk of balance, balance simply means they used identical impedance in each of the phase. They use identical impedance in each of the phase. And if we use identical impedance in each of the phase, it means we can take one and just work with that one, and then we just divide or multiply by 3. So they gave us the total power. So the total power for the 3 phase. So total power. So in our solution, total power PT is giving us 12 kilowatts. So if I have 3 phases and the total power in all the 3 phases is 12, and they are telling me that it is balanced, it means to get the power in each single phase is going to give me 12 kilowatts divided by 3, and this is going to give me 4 kilowatts. So it means per every phase we have this power moving in that phase. So we've started with the A. And you learned when you are treating single phase that if total power is given to you and they have given you power factor, always your power, your effective power, is given by VP IP cos theta, where cos theta is the power factor. So the question said we should find the phase current. So IP is going to be equal to the power, or the power in the single phase, all over the VP cos theta. So the PS is given to be 4 times 10 to the power 3 watts. And the VP is also given to be 450 volts times the cos theta. The angle wasn't given, but the power factor has been given. And we know cos theta is the power factor. So you just put it there straightforward, which is 0.8. What are you going to get? You are going to get IP to be 11.1 ampere. So our IP is 11.1 ampere. Then what will be the line current? What is the line current? In the question they said this was a delta connection. So if it is delta, we know that, okay, so B, we know that line current is equal to root of 3 phase current. So we will get root of 3. What is the phase current? The phase current, we have 11.1 ampere. So when you multiply the two, you are going to get 19.2 ampere as your line current. So now that we have our line current, the last one said we should find the effective impedance. If you want the effective impedance per phase, it is just the voltage across that phase. So you pick your voltage. You know that ZP, which is our impedance per that phase, will be equal to VP over IP. But the VP is the voltage supply, so they gave us 450 and it is at an angle of 0. But this one, because there was power factor, you can't straightforward say that the current is also at a phase angle of 0. They gave us a power factor, so the power factor can help us get the angle. So they said lagging. So the phase current, we had 11.1. But because they said it was lagging, it means the angle is minus. And you are going to take cos inverse of the power factor that we were given, which is 0.8. And when you put this thing on the calculator, you end up getting the phase impedance to be 40.5 angle 36.9 degrees. So that brings us to the end of question solving on three-phase systems. Thank you.